This laptop used to work quite well, but over time not so much. Its gaming performance dropped, while the noise it generated clearly increased. On top of that, the whole case became very hot. If you have a similar problem with a mid-range laptop, a netbook, or even a high-end gaming beast, this video will be more helpful for you than anything you've tried so far. I'll show you how to clean the cooling system, how to properly secure and apply liquid metal, which will lower the temperatures of both the processor and the GPU. In some cases, even by 20% or 30 degrees. Wow! And lower temperatures will not only make the fans run much quieter, but they can also boost your laptop's performance to levels it has never reached before. Because the original, or even a regular replacement thermal paste, simply didn't allow it. So sit back and let's get started. You can watch this video thanks to the support of the GVG Mall platform. It's a huge store specializing in keys for PC, Xbox, PlayStation, and even Google Play games. You can get practically everything here, from Steam gift cards to software like Office or Windows. If you're still struggling with that annoying message reminding you to activate, visit the link in the description right now. You'll receive the purchased key within a few minutes, and all you have to do is paste it into the activation settings. This will not only legalize your version of the system, but also allow you to upgrade to Windows 11 without any problems. You can activate and assign the Office package to your account just as easily, and with the code TMHD you'll get an extra 20% discount, which can go up to 30% during various holidays and events. Stop overpaying and visit the website now. It would be appropriate to start this material with a brief explanation of what liquid metal actually is and why it is much better than commonly used thermal pastes. Well, the exact composition and proportions are a trade secret and of course may vary depending on the manufacturer, but we do know for sure that liquid metal is a mixture of elements such as tin, gallium, and indium. In the vast majority of computers and laptops, thermal pastes are used. It's a cheap solution and easy to implement in mass production. It doesn't require special precision or preparation. It's even possible to pre-apply the paste, so the buyer of something like this liquid cooler doesn't have to do any additional steps related to applying the paste. However, the problem is that over time, the performance of the pastes decreases, which is why a new laptop runs relatively quietly at first. But after a year or three, the way it runs deteriorates significantly. The paste dries out completely and no longer serves its purpose. As a result, we end up with a constantly howling computer. In extreme cases, under heavy load, it even starts shutting itself down. The second and quite serious drawback is their limited performance. The lower quality ones, often containing just a silicon mixture, have thermal conductivity around 1 to 2 watts per meter Kelvin. The mid-range ones reach performance around 4 to 5 W. On the other hand, the most efficient pastes, thanks to the addition of zinc oxide, aluminum, silver, and sometimes even synthetic diamond, achieve from 8 to 12.5 WMK. This is pretty much the maximum for thermal pastes. That's why liquid metal, which in this case has a conductivity of 73 W per meter per Kelvin, is absolutely unbeatable. So the fact that some of the top gaming laptop manufacturers have also turned to liquid metal shouldn't surprise anyone. Of course, it's difficult and expensive to implement in mass production, but no one said it was supposed to be impossible. As you can see, Asus uses exactly the same thermal paste that we're going to use in this video. Even the PlayStation 5 relies on liquid metal for its cooling. However, metal in liquid form has a few drawbacks. The first one is that it's an excellent conductor of electricity. When applying regular thermal paste, if you use too much, basically nothing bad will happen. If you do the same with liquid metal and, for example, spill it on the surface of the circuit board, it may, or almost certainly will, cause a short circuit. Of course, if such a situation happens and we notice that we've made a mistake somewhere, we can collect the excess liquid metal or suck it back into the syringe. However, don't worry, I'll show you the safest way to apply the metal and how to properly prepare the surface to greatly minimize any risk. Many people are also afraid of using liquid metal because it can have an undesirable reaction with some metals. Of course that's true, but it's not something that should be a taboo topic. You just need to remember these 3 things. The first thing is that we don't use liquid metal with aluminum, which means with those usually cheapest, weakest heat sinks. Liquid metal corrodes aluminum, which is something we really wouldn't want. However, using it with copper is considered completely fine. It's safe, although in this case there is slight surface electrochemical corrosion due to the presence of different potentials. The gallium contained in the liquid metal has a negative potential, while copper has a positive one. Thus, gallium migrates toward the copper, which gently, so to speak, dries out the product we applied. However, this is not a cause for concern. It's always worth monitoring the temperatures, and if after a few weeks or even a few months from the first application you notice a drop in performance, it's enough to reapply the liquid metal to the surface, which will restore the optimal composition of elements. The third type of surface you will encounter is nickel-plated surfaces. You can most often find them in liquid cooling blocks, but also on IHS surfaces, which are the caps covering both Intel and AMD processors. Using liquid metal here is completely safe, no significant reaction occurs. The only thing is that after prolonged contact you may notice slight discoloration, but in most cases it can be wiped off with acetone. Most importantly, this discoloration does not affect performance, it's only a cosmetic issue. So the matter is very simple. We never use liquid metal with aluminum, ever. However, with nickel-plated surfaces and copper, it's absolutely fine. However, in the case of copper, you might need to reapply the paste, which is actually very easy to do again. I know, I got the concept. And now that we understand what we're dealing with, it's high time to proceed with the actual procedure. To carry it out, we need not only liquid metal, but also a few additional components. Isopropyl alcohol will help soften and remove the old, dried thermal paste from the surface. The varnish, along with insulating tape, will be used to protect the area around the processor and graphics chip from any possible liquid metal leakage. If you're performing this procedure on a laptop, it's not always mandatory, but it's generally recommended to also replace the thermal pads. Don't worry, no need to panic. Everything I mentioned is in the pinned comments and the description. This will save you a lot of searching, because the links themselves lead directly to the price comparison site. So, whatever you need, you'll buy it where it's cheapest and most convenient for you. If you haven't started taking apart your laptop yet, it's a good idea to check the manual for your specific model before you begin. After removing the cover, locate the battery and disconnect its cable from the motherboard. In some laptops, accessing the cooling system is extremely easy, and it's located right under the cover. In others, it can be a complicated procedure, so remember that rushing is your enemy and caution is your friend. Once you get through this stage, remove the excess dust from the fan and blow it out with compressed air. Alternatively, you can clean it with the appropriate nozzle. Just remember not to let the fan spin up, as this could damage it. Just gently hold the fan blades with your finger. Now, loosen the cooling system screws, starting from the last number and moving to the first one, then unscrew them completely. Some thermal pastes can actually glue the heatsink to the processor, so instead of pulling it straight up, try making a gentle twisting motion so the paste loosens, and slowly lift the cooler, paying special attention to the radiator, or the radiators located between the fan and the air outlet in the case. Don't force it, just find the right angle to gently pull everything out. Here again, you might find a lot of accumulated dust, so gently remove it and be careful not to bend the fins. I recommend cleaning the removed heat pipes first with a kitchen towel using a dry method. Toilet paper tends to crumble and tear, so it's not the best choice. When you've removed most of the residue, soak a paper towel with isopropyl alcohol and continue the cleaning process until you achieve a perfect result. Cleaning the cooling system doesn't require any finesse, but be especially careful with exposed silicone, because if you pull too hard, the paper towel can catch on a sharp edge and break it off. That's why you should make a motion that goes off the edge of the chip, so to speak, not onto it. The next step is to protect the surface side against possible metal leakage. To do this, apply the first layer of varnish and wait about 30 minutes for it to harden. In the description, I'll leave a link to the Thermal Greasy brand varnish, which was created specifically for this purpose and can withstand high temperatures without damaging the PCB. However, I will use a different, colorless but proven nail hardening varnish. After the first layer dries, it's a good idea to apply a second one and also wait another 20 minutes for it to dry. In theory, this alone should be enough, but if you want to be extra cautious, an additional physical layer shouldn't hurt either. So we covered the critical points with electrical tape. You'll also find a link to a special type with increased heat resistance in the description below this video. However, before you decide on this extra protection, make sure that adding another layer around the core, even something as thin as electrical tape, won't reduce the pressure from the heatsink to the surface of the core, since that's where we ultimately want to draw the heat from. While we're still on the topic of preparations, the next, but optional step is to mark the boundaries on the surface of the heatsink where you'll later spread the liquid metal. For this purpose, we can use any electrical tape we already have, or even better, painter's tape. Once you've prepared and secured everything, wipe the surface again using isopropyl alcohol. Because during that time, dust particles or grease from our fingers may have accumulated on them. And here, I have to say that the wipes included with the thermal greasy kit aren't perfect because they leave behind a lot of fibers. They're soaked with the right kind of alcohol and you can use them, but then wipe the surface once more with a clean paper towel so that nothing is left on the core. So let's get to the point. And no, don't squeeze the liquid metal directly over the surface of the processor. That could end very badly. Squeeze a small amount onto a clean dish or, even better, directly onto the applicator pad included in the set. Even if you squeeze out too much, you can always draw it back into the syringe. At first, applying liquid metal to the surface of the processor or the heatsink might seem concerning, but don't worry. It's just surface tension that causes one to repel the other, but rubbing for long enough breaks this barrier. We keep rubbing until we achieve the desired effect on both the silicon surface and the heatsink. The most common question is how much metal we should use, but you just need to follow one very important rule. Listen to me very carefully. You don't apply liquid metal like you would spread a layer of jam on a slice of bread. You just need to spread it around like chalk across a blackboard. Once you've spread a sufficiently thin film over all surfaces, remove the tape marking the border from the heat spreader if you applied any, and install the cooling system, making sure to tighten the screws this time according to the numbering next to them. Next, connect the battery, put on the cover, and turn on the device. After disconnecting the battery, the startup process may take a bit longer than usual, but that's normal. To check if this whole procedure brought us any tangible benefits, I ran a few tests. Stressing the processor with the CPU burner program proves that the benefits of changing the thermal paste to liquid metal are definitely real and measurable. 6.4 degrees may not sound shocking, but what this laptop doesn't show is the fan speed, and here you'll have to take my word for it, the fans were definitely running much quieter. However, keep in mind that the previously used thermal paste here is one of the better ones. The data presented here was collected when the paste was fresh and also after thoroughly cleaning the fans, filters and radiators. From the chart, you can see that I also included the amount of power consumed by the processor in the measurements, which is represented by the blue bar. This value, expressed in watts, has a direct impact on the processor's performance. The higher it is, the better. Simply put, a greater amount of supplied power allows the processor to maintain higher clock speeds, and higher clock speeds mean more computing power, which translates to a faster computer and more frames in games. But here's the thing, for the firmware to even allow the processor to draw more power, its temperature has to be lower. Otherwise, it could get damaged. That's why these two values are connected, and we should consider them as a pair. However, not everyone pushes their processor to 100% all the time. Starting the computer, loading the desktop and all the startup programs, as well as internet browsers, takes up to a minute on a relatively new laptop. Also, for most of you, processor performance is more important in these shorter intervals. For example, when we're loading a game. That's why the next set of bars perfectly represents how the computer behaves under such a load. In the first minute, when the processor boost is maintained around 40 watts, the overwhelming advantage of liquid metal becomes apparent. With thermal paste, the temperature reaches almost 78 degrees Celsius. After applying liquid metal in the same test at the same time and under the same test conditions, we get just 61.4, which is 16.5 degrees lower. Undeniably, that's a huge difference. I know there are a lot of these charts, but I really like to create comprehensive materials, the kind that give us a complete picture of the situation. And since, realistically, hardly anyone decides to leave the laptop fans on turbo mode all the time, I'm now showing you the results including the balanced fan profile, the one you probably use every day. I find the recorded values incredibly interesting, and after analyzing them, we can draw some important conclusions. In this particular laptop with thermal paste, setting the fan to maximum and then to the balanced profile results in only minimal temperature differences, and if we hadn't measured the power consumption, we would probably think that it doesn't make any difference. However, reducing the power consumption from 40 to 36 W is nearly a 10% drop, which forces the processor to lower its clock speeds, and as you guessed, this affects performance. On the other hand, if we compare the results achieved with liquid metal, we can see that at lower fan speeds, we not only have much lower temperatures, but the firmware still allows it to draw higher amounts of power, which is exactly right. The processor then maintains higher clock speeds and operates more efficiently and faster. However, we applied the metal not only to the processor itself, but also to the graphics chip, and as we can see, an improvement was also noted here. Maybe it's not as shocking as with the processor, but it's still something. Of course, these results will vary depending on the laptop, its cooling system, the power of the graphics processor, and even the performance of the power supply system. Firmark is commonly called a power virus for a reason. It's not meant to render the highest number of frames, but its purpose is to generate such a load on the graphics processor to cause the highest possible power consumption. And yes, the temperatures themselves improved with liquid metal. With balanced fan speeds, the temperature of the graphics core during a short performance burst was reduced by 7 degrees. After a few minutes of such load, these values are still 2 degrees better, but we can also see that the power consumption has been limited in basically each of these cases. Why does this happen if the temperatures are lower? Well, it seems that the VRM, that is the graphics power supply system, seems to be struggling. Unfortunately, this laptop doesn't have a temperature sensor on that system, so it's hard to verify what the difference is, but there definitely is one. We also have to remember that the lower graphics temperature caused the fans to spin slower, so for that reason, the power supply system simply had a harder time. Because after all, everything is cooled using that one shared heat sink. How does actual performance compare in Passmark, for example? With thermal paste in balanced fan mode, the processor scored 8,186 points. With liquid metal, it was already 8,687, which means a 6% increase in performance. At maximum fan speeds, the advantage dropped to 4.5%. As you can see, the graphics system in this case didn't gain as much as we would have liked. At least that's what it might seem to us, but don't be disappointed by this because GD007 paste is actually a really solid thermal paste. That's why if your laptop has old, dried out and really worn out thermal paste, in extreme cases you might even see several times better performance from your graphics system. This isn't an exaggeration. I'll share an example from my own life. A few years ago, I bought a cheap Alienware gaming laptop with an Nvidia GT 650M inside. The man who sold it to me considered himself an IT specialist and claimed that gaming laptops are junk because after 2 years of use, he was only getting 12 frames per second in World of Tanks. No wonder, since the overheating graphics card was running at around 180 MHz. After replacing the old thermal paste with new one, the clock speed jumped to 900 and it was possible to play comfortably at over 60 frames per second. This simple procedure saved me 4,000 zlotys back then, so yes, if you have old thermal paste, doing this can bring you huge benefits. So it's really worth it, and this material is worth analyzing thoroughly. Watch it a second, maybe even a third time if necessary. I'm sure that properly replacing the thermal paste with liquid metal will give your device a second life. And if you really want to try, but all of this seems overwhelming, maybe instead of liquid metal, just use thermal paste at least for the first time. You won't need to use any protective measures then, because the paste, at least the ones I'm testing in the next video, doesn't conduct electricity. The link to the test and comparison of pastes is in the top right corner of your screen. Also, don't forget about your friends who might have a similar laptop problem. Do them a favor and be that awesome friend who sends them the link to this video. If you like this video, a thumbs up and a comment would be the best gift.